Okay, good morning, class. Right. So I come back to PDPR. Okay, again. Okay. Before I start my class, we can please check the attendance. So it's still not here, so I can put the names in the parents group. Okay. So today before I start the class, right? So I want to say something about your project, right? So I did all of you already have the project that you want to do? Is still anyone who didn't know what to do for their physics project? Okay, so let me Prisha, Lashmi, Nirupa, Tava. Okay, so I put the name in the parents group. Okay, so I just want you to know that actually for the physics project, okay, it's not the experiment. It's not the experiment. It's not the like application, like activity, right? What you want to prove. They say if you want to prove there is a inertia, right? So you put like a coin, okay, on the top of the cardboard. Then when you drag the cardboard, the coin will fall into the glass. That is not a project, right? That is actually activities, right, to prove there is inertia. Okay, and also there's experiment. Okay, experiment also, it cannot be said that that is a project. Okay, so I want a model. Okay, so means you use the physics project, okay, to invent something. Okay, so like water rocket, okay, or maybe a car, right? So you modify the car to make the car, the acceleration of the car, okay, higher. Okay, so that is the project. Okay, so I want just to make sure that you are very clear, okay, what is actually the physics project. Okay, and for you that like some of you do the common things, right? Some you use the water dispenser. So that's one is, yeah, that is a physics project. Okay, but that one is a very simple one. Okay, so make sure like maybe you can do some modification, okay, to the water dispenser, okay, using the physics concept that you learn or okay, then maybe I can give you a mark because there's so many, like some of you requested to me that you want to do the same thing like your friend. Okay, so I give you like, okay, you can, but you need to do some modification. Okay, so it's like 1 month from now, so if you have any problem you can text me. Okay, make sure you record all the process that you did. Okay, maybe you how you do the experiment. Okay, take the picture or video and make sure the project is function. Okay, so let's say for the water racket, so it really can launch. Okay, you have to show the video that actually the water racket that you do, okay, it can actually launch. Okay, so it's really functioning. Okay, so who's still not here? There are three people. Just now I see someone enter, right? Okay, Tava is here. So two more person. One left. Who? Nirupa. Okay. Wait, I put in the parents group first. Okay, so let's continue. So today we learn a new chapter. Okay, chapter 4, heat. Okay, so we go for the first subtopic in the chapter 4. There is a thermal equilibrium. Okay, so what is actually a thermal equilibrium? So that is what we will learn, okay, today. So what is actually a thermal equilibrium? So before you learn about the thermal equilibrium, okay, so you have to know, okay, you have to know. So let's say there is a coffee, right? So there is a coffee and you put the cold spoon, a spoon, okay, inside the coffee. So the coffee is hot, right? So there will be a transfer of energy, the transfer of heat energy, okay, from the coffee to the spoon. Okay, so means you have to know that heat is transferred from the hot object, okay, to the cold object. Okay, and must be the two object must be in contact. Okay, in the thermal contact, so that the heat can be transferred. All right. Okay, so when the cool metal spoon is put into a cup of hot coffee, okay, the spoon and the coffee are said to be in thermal contact. Okay, so the heat energy can be transferred between the two bodies. So what is the final condition of the spoon and the coffee? Okay, so the second one is let's say you hold the hot kettle. Okay, so a boy feels the heat of the kettle. So why? Because the heat of the kettle transferred to the hand of the boy. Okay, so this is actually to generate the idea that actually the heat is transferred from the hot object to the cold object. Okay, and then for the ice, why ice is melting on your hands? Okay, so means the heat from your hands, okay, transferred to the ice, so the ice now absorb the heat, so it melts. Okay, so the ice melt when is in the boy's hand, so the boy's hand is cool. Why? Okay, so when the heat is transferred to the ice, so now the hand of the boy, okay, is experience the loss of heat. Okay, so when there is loss of heat, the temperature will go down, right? So that's why the boy's hand feel cold. Okay, so this one, the boy takes his hand away from the kettle because of the boy feels the heat of the kettle. So this is the reflex reaction, right? And the heat is transferred from the kettles to the boy's hand. Okay, so heat is transferred from hot object to cold object. Okay, so for the ice melt when it's in the boy's hand. So the boy's hand is cold. So the heat transferred from the boy's hand to the ice. Okay, so when the ice receive the heat from the hands, okay, it will melt. Okay, it will change from solid to liquid. Okay, so the heat is transferred from hot object to cold object. Alright, so what is heat? Okay, so heat is a form of energy. So you know there is a lot of type of energy. So like example, electric energy, light energy. Okay, so actually heat is one of the form of the energy. Okay, so what is the temperature? Temperature is the degree of hotness. Okay, and the unit for the temperature is Kelvin. Okay, this is for the SI unit. So let's say if you have a degree Celsius, okay, so let's say they give you 27 degrees Celsius. So how you want to change to Kelvin? So you just add plus 273. So you will get 300 Kelvin. Okay, so that's how you change from degree Celsius to Kelvin, because at the end of the chapter you will learn about the gas law. So for the gas law, the temperature, you must change the temperature from degree Celsius to Kelvin. So this is how you change from degree Celsius to Kelvin. You just add 273. Okay, so we compare about the temperature and heat. Okay, so the temperature is a degree of hotness. That's the definition. Okay, and the heat is the form of energy. So in exam, so let's say they ask you what is the meaning of the temperature. So you just say degree of hotness. Okay, and for heat, okay, you just say it's a form of energy. Okay, for the SI unit for the temperature is Kelvin. Y for the energy is joule. So any energy, okay, for the let's say electric energy, light energy, okay, or maybe elastic potential energy, gravitational potential energy. So any type of energy, the SI unit must be in joule. Okay. Alright, so the measuring device for the temperature is a thermometer, okay, while heat is a calorimeter. Okay, so this one we do the experiment. So let's say if you have a chance to come back to school, okay, so we do the experiment about the you will see what is actually the calorimeter. Okay, and for the temperature is a base quantity, okay, because it's you cannot simplify, right? This is the simplest unit. Okay, so this is the base quantity, and the heat is a derived quantity. Okay, so the you can derive from joule, right? It's a joule is actually the a short form. So if they say if you want to form the energy, elastic potential energy, you already learned this one on form 3, right? Okay, Fx. Okay, this is the elastic potential energy. So force is actually MA. Okay, so there is a kg ms negative 2. Sorry, I like E is half Fx. Okay, so F is equals to, wait, what's wrong with my pen? F is equals to ma. So m is a kg, sa is the acceleration, ms negative 2. So kg ms negative 2. X is actually is a compression, right? So this one is in meter. Let's say it's in meter, you change to meter. So you will get kg m square s negative 2. Okay, so this is the derived quantity. It consists more than one base quantity. Okay, one or more. Okay, for the base quantity. So you can see there are 3 units here. So this is a derived quantity. Okay. All right. So when an object is heated, okay, so whether it's a heat is absorbed or released, so heat will be absorbed, okay, absorbed, and then what happened to the temperature, so the temperature will increase. Okay, so what happened when the object is cool? Okay, so the heat will be released, okay, and the temperature will be decreased. So this is the example. So they say you put a drink inside the refrigerator, so you will see that heat will be released and the temperature of the of your drink, okay, will be decreased. Okay. All right. So now, okay, to show thermal equilibrium between two bodies in thermal contact. So let's say this is the experiment. Okay, let's say we did in the lab. Okay. So you have a two beaker here. Okay. So the beaker B you fill with the hot water here. Okay, and then you put inside the beaker A that is much bigger. So you put the tap water inside the beaker A. Okay, so it's like you just immerse the beaker B, okay, inside the beaker A. Okay, and then you put the tissue paper here. So what is the function of the tissue paper here? This one is actually to make sure that there is no heat loss to the surrounding. Okay, sometimes you use a felt. Okay. Okay, and then so we put the two thermometer here. The first thermometer A, we put in the tap water. Okay, and the thermometer B we put in the beaker B. Okay, all right. So beaker B that consists of the hot water. Okay, so now, okay, we will record. Okay, so this one is actually already explained just now. Okay, so we fill the 40 milliliter of 50 degrees Celsius hot water into the beaker B. So inside of the beaker B, you fill with the hot water that is a 50 degrees Celsius. Okay, and then after that, okay, this one already explained just now. Okay, and then you have to record the thermometer A and B every 30 seconds. Okay, so every 30 seconds, you will take the reading for the thermometer A and thermometer B. Okay, so until the reading of the both thermometer are the same. Okay, so let's say this is the reading. Okay, so from the first, when you start the experiment, you take the initial temperature. So the temperature of thermometer A, okay, the temperature of the thermometer A is 27 degrees Celsius. Okay, and for the thermometer B, there is a 50 degrees Celsius. I'm not sure why my... Can you wait for a moment? Give me 1 minute. Okay. So after 30 seconds, okay, you take the temperature for thermometer A, the one that you put in the tap water, right? So you can see it increase. Okay, and then for the thermometer B, okay, you put the hot water inside of it, right? So it will be decreased. Okay, so it will keep increase. Okay, so every 30 seconds you take the reading. Okay, you take the reading until both of the thermometer give the same reading. Okay, so you can see the thermometer A, right? That one that you put in the tap water is keep increasing. Okay, while the thermometer temperature of thermometer B, okay, it keep decreasing. So means that this proof that there is a there is a transfer of heat here, right, from the hot to the cold object. Okay, from the hot to the cold object. So hot water release heat to the tap water. So the tap water absorb heat from the hot water, and transfer of heat occurs when the two bodies are in the thermal contact. So from the hot water, it will release the heat to the tap water. I'm not sure why I didn't wait. Okay, so from the heat from the hot water transferred to the tap water. Okay, so you can see that's why it keep increasing. Okay, the temperature. By the thermometer, it lost the heat, right? So you already learned that when an object lost the heat, okay, the temperature will be decreased. Okay, so when the two water are in the thermal contact, the temperature of the hot water decreases while the temperature of tap water increases until the temperature of the both object become the same. So at the 300 second, you can see here both of the thermometer give the same reading. Okay, so this one we call it as a thermal equilibrium. Okay, means the transfer of heat, okay, between the two objects are already same. Okay, so this one, the condition here we call it as a thermal equilibrium. Okay, so what causes the change in temperature? Okay, so this one I already explained. Okay, discuss the transfer of heat between the hot water in beaker B and the tap water in beaker A. Okay, alright, so the heat is transferred from the hot water in the beaker to the tap water with the high rate. Okay, so the hot water at the 50 degrees Celsius, okay, they will transfer the heat to the tap water, okay, in the high rate. Okay, but there is also the heat transfer, okay, from the tap water, okay, to the hot water, okay, but in the very low rate. Okay, so means there is a heat transfer between both, right, between the hot water and also the tap water. Okay, but the hot water transfer more heat to the tap water than the tap water transfer the heat to the hot water. Okay, so this will occur until both of the liquid or both of the water have the same temperature. Okay, so state the direction of the net heat transfer between the two objects. So the direction of the net heat transfer is from hot water in beaker B to tap water in beaker A. Okay, but the temperature hot water decrease, so heat will be released, while the temperature of the tap water increase, so heat will be absorbed. So any object that release the heat, the temperature will be decreased. Okay, while the object that receive the heat, okay, the temperature will be increased. Okay, so any question you want to ask teacher before I move on? Are you clear? They say if I'm going too fast, please tell me. Okay, Janet, can you understand? Eugene, Farah? Okay, so next we compare the temperature of both thermometer after 5 minutes. Just now like we did the experiment, we wait until 300 seconds, right? So 300 seconds is actually equals to 5 minutes. So after 5 minutes, what will happen there, we can see that the both temperature of the tap water and also for the hot water, it becomes same, 37 degrees Celsius. Okay, so that time we call it, it's already reached the thermal equilibrium. Okay, so what happened to the rate of the heat transfer after 5 minutes? So the heat transfer at the same rate. So let's say I transfer this one 300 joule, okay, from the tap water to the hot water, and the hot water also will transfer 300 joule, because remember I said just now there will still a heat transfer for the tap water to the hot water, but it's a very low rate. Okay, while but for the hot water to the tap water, it will transfer the heat at the high rate. Okay, so it will keep be like that until both of it transfer the same amount of energy between the two type of water. Okay, so means they transfer 300 joule to the hot water, and the hot water gives 300 joule also to the hot water. Okay, so then it become the same. Okay, so heat transfer at the same rate, okay, between the hot water in beaker B to tap water in beaker A. Alright, so the next one, so what can you say about the net rate? Okay, so just now I said the transfer 300 joule, and this one also give 300 joule. So what will happen? So 300 minus 300, so the net rate will become 0. Okay, so there is no net heat transfer between both reading. So the net rate of heat transfer is 0. So both hot water and tap water, okay, are in state of thermal equilibrium. Okay, so this is the meaning of the thermal equilibrium. So let's say in exam they ask you what's the meaning of thermal equilibrium. So you can answer these 3 sentences. Okay, so this one you need to remember. The temperature, okay, the temperature for both object, okay, is same. Okay, and the rate of heat transfer between two objects is same. And the last one, the net rate of heat transfer is 0. Okay, so this is the 3 sentences that you need to write if let's say they ask you what is the meaning of the thermal equilibrium. Okay, and let's say for the paper 1, okay, if they mention the thermal equilibrium, okay, just need to find the answer that give you the sentence, the 3 sentences. Okay, these 3 sentences, so that will be the answer. Okay. All right, so thermal equilibrium. So there is a no net heat flow of heat between two objects. So two objects have the same temperature. Okay, so this one I already explained. Okay, so this is the example. Let's say this is the ice, right? And then this is the hot water. Then you put the hot water, okay, into the ice. Okay, so you can see the hot water, okay, it keep increasing. Okay, the temperature, while the hot water will decrease, okay, and there will be the heat transfer between these two, okay, and there will be, they say this is 500 joule, it give the 500 joule to the hot water, and this one also give the 500 joule. So at 500 minus 500 you will get 0, so the net rate heat is 0. Okay. Okay, so what is the function, or what if we use the principle of thermal equilibrium in our daily life? Okay, so a wet towel. Okay, so let's say you have a fever. Okay, so when you have a fever, you put the wet towel placed on the is placed on the forehead of the person who has a high fever. So the first one, what will happen? Okay, the heat will transfer. Okay, so this will be the example, like the 4 marks, the explanation. Okay, because you know on question number 9 and number 10, there will be the explanation. Okay, explanation question. Okay, 4 marks. Okay, they ask you to explain. Okay, so let's say for example they ask you, okay, what will happen, what will happen when you put the wet towel, okay, on the forehead for the person that has a high fever. Okay, so the first one you have to mention that the heat is transferred. Okay, the heat is transferred, okay, from the person, okay, let's say from the patient, okay, to the wet towel, 1 mark. Okay, and then the second mark is, okay, you have to mention that, okay, the rate of the heat transferred, okay, the rate of the heat transferred, okay, between the towel, the wet towel and the patient, okay, is same. Okay, and then you have to mention until it reach thermal equilibrium. Okay, the rate of heat transferred, okay, the rate of heat transferred between the wet towel and the patient, okay, is same, okay, until it reach the thermal equilibrium. Okay, and then the last mark, okay, the last mark, okay, you have to state, all right, the temperature of the wet towel, okay, is equals to the temperature of the patient. So that is the 4 marks. Okay, that's how you want to explain. Okay, so for this one, it said that initially the temperature of the clothes is lower than the body temperature of the person. So this one you need to explain for the question, for the 4 marks question. This one you need to put. Okay, so it start from here. Okay, so the heat energy is transferred from the forehead to the towel. So 1 mark. Okay, so this you get 1 mark here. Okay, and another mark, let's say this one I already told you, anti-thermal equilibrium is reached, 1 mark. Okay, so this one, the third one, the third and the fourth mark is, okay, so let's say this one come out in your exam. Okay, you have to say the rate of heat transfer, okay, between the forehead of the person, okay, is same with the wait. Mm, wait, I changed the sentences. Rate of heat transfer between hot towel and the person is same. Okay, and number 4, the fourth mark, the temperature of the towel is same as the temperature for the person. Okay, so this is how you want to explain. Okay, for the explanation question, okay, let's say they ask you to put the wet towel. Sometimes they ask you to explain the cold packs, right? So that one also you can use this one. Okay, it's the same function. Okay, so the first mark is from here, the heat energy is transferred. Second mark is thermal equilibrium is achieved. The third mark, you have just mentioned the meaning of the thermal equilibrium. So this is actually the number 3 and number 4 point. Number 4 point is actually the meaning of the thermal equilibrium. Okay. All right. So let's see for the next one. Okay, the cooling drinks. Okay, so the hot drink can be cooled by adding a few ice cube to the drink. So the heat transfer from the hot drink, okay, to the colder ice. So then the ice will be melt, right? So until it reach the thermal equilibrium between the ice, okay, between the ice and the water. Okay, so the ice cube will melt, okay, and then the temperature of the drink decreases and the drink cools. So this is how you explain for the cooling drinks. Okay, and the next one is, let's say you put the cool object in the refrigerator. Okay, let's say just now I explained to you about the, yeah, let's say you put the water inside the refrigerator, right? Okay, so the object, when the food is kept in the refrigerator, So the heat from the food flows to the air in the refrigerator until the thermal equilibrium occurs. Okay, so the temperature of the food will drop and the food will stay fresh for a longer period. So because this one, the microorganism is not active, right? If the surrounding is too cold. Okay, and the next one is a baking cake in an oven. Okay, so the hot air in the oven is a thermal contact with the cake batter. Okay, so the heat from the hot air flows to the cake batter and then this causes the cake batter to be heated until it baked. So this one, I think you can explain. You already know that inside the oven is hot. It consists of hot air. So the hot air will heat the cake batter, okay, and then the cake batter, the temperature will increasing, okay, so until it baked, okay. And the next one, so this one is actually the clinical thermometer. Okay, so this is the same as the cold pack or the wet towel that we just discussed just now. Okay, so let's say you put the thermometer, okay, under the tongue, okay, and then the heat will flows, okay, from the from the patients to the thermometer. Okay, so the thermometer, the mercury will expand inside the thermometer, okay, and until it will reach the temperature is the temperature of the thermometer and the patient will be same. So this one we said that it's already reached the thermal equilibrium. So for this one you can use the one that I gave this one. It's just same. You just change the hot towel to the thermometer. Okay. Alright, so the next part is the calibrate in liquid, okay? A liquid in glass thermometer using a two fixed point. Okay, so let's say you have a thermometer. Okay, you have a thermometer. So that thermometer, okay, is still not calibrated. So means that it doesn't have scale. Okay, so how you want to determine, okay, what is the temperature? Okay, let's say if I give you a thermometer, but there is no scale. Okay, so and then how you want to measure? Let's say I give you liquid X. So how you want to measure a liquid X? Because there is no scale on the thermometer. So you can calibrate the thermometer. Okay, you can determine the scale of the thermometer. Okay, and all the temperature of the liquid X that I gave. Okay, by using the two fixed point. What is the two fixed point? So means this the two fixed point is the melting point and also the freezing point. Okay, the melting point that or the freezing point. So how you want to do the experiment? So so let's say if I have a ice, okay, I have a ice, okay, so I put the thermometer inside the ice. Okay, so I put the thermometer inside the ice. Okay, and then I measure the length of the mercury. Okay, and then I measure using your ruler. Okay, I measure the length of the mercury when I put, the thermometer inside the ice. Okay, so that will be the L0. Okay, that will be the L0. Okay, so let's say if I have a thermometer here. Okay, so let's say this is thermometer. I put inside the ice. Okay, so there is the ice here. Okay, and then the temperature will increase, right? So let's say it stop until here. Okay, so and then I take the thermometer, I measure it with ruler. Okay, so let's say that one is called as L0. Okay, the length of the thermometer when when the process of melting occurs. So you already know the ice melting at 0 degrees Celsius, right? So that's why we call it as a L0. So L0, let's say when I put in the ice, okay, and then and then I take out the thermometer, I measure using the ruler, the L0 is 2 cm. Okay, so remember L0 is the length of the thermometer when 0 degrees Celsius or when it's a melting point, or sometimes they call it as a freezing point also. Okay, and then after that, I put the same thermometer, okay, inside of the boil water. So you already know that water boil at 100 degrees Celsius, right? So let's say the temperature increase, okay? It increased until L100 is 12 cm. Okay, so I explain again. First I put in the ice. Okay, so the temperature increase, then I take out, then I measure, so that one will be L0, the length of the mercury when the temperature is at 0 degrees Celsius, or at freezing point, or at melting point. Okay, so you have to be careful that we mention sometimes they will not tell you that it's a 0 degrees Celsius. Sometimes they use the melting point or freezing point. Okay, and then the second one, I put the thermometer inside of the hot water of the boiling point. Of the boiling water. So the temperature of the boiling water, you already know that is 100 degrees Celsius. So that one will be L100. Okay, so when I put the thermometer inside the boiling point and I take it out, then I measure again, okay, the thermometer, I measure the mercury, okay, the length of the mercury. So I got 12 cm. Okay, so that we call it as a L100. Okay, so L theta is the one that I need to found. So let's say I measure I put the thermometer, okay, inside the liquid X just now. Okay, and I measure the length of the mercury is 7 cm. Okay, so by using this L theta L100, okay, I can know what is actually the temperature of the liquid X. Okay, so I explain again. Put the thermometer inside of the ice, then take it out. Okay, then measure the thermometer, the length of the mercury. You got 2 cm, and then after that, I put again the same thermometer inside the boiling water. Okay, and that one is L100 because the boiling water is is 100 degrees Celsius, right? So I measure again the length of the thermometer. Okay, the length of the mercury. Okay, so I got 12 cm. Okay, and then I put in the liquid X. Okay, I put in the liquid X, I see the length of the mercury is 7 cm. Okay, so I got 3 info already. Then based on these three info that I already know, I can calculate the temperature of the liquid X. Okay, by using the formula. Okay, L theta is L theta minus L100. L theta minus L0, L100 minus L0 times 100. Okay, so this formula you need to remember. This one we're not given in the exam. Okay, L theta minus L0 divided by L100 minus L0 times 100. Okay, so that is actually explained, okay, for this slide. Oops. Okay, so state what happened to the liquid in the capillarity of thermometer when the heat is absorbed. So you already know the liquid will expand. So inside of it is actually mercury. So mercury will expand. Okay, so what does the length of the liquid in the capillarity indicate? So it indicates the magnitude of the temperature. Okay, so this is the calibration process in making a scale of reading on thermometer. Okay, so 0 degrees is the fixed lower limit. So fixed lower limit means is 0 degrees. Okay, and 100 degrees is the fixed upper limit. So upper limit is 100 degrees. Okay, so the length of the liquid column between the fixed lower limit and the fixed upper limit is divided into 100. So you can divide 0 degrees until 100. So you divide into 10. Okay, 10 scale. Okay, so the thermometer is then calibrated and can be used to measure the temperature between 0 and 100 degrees Celsius. So if you put in the ice, you already know, say the length of the mercury is here. So you put the inside the boiling water, the length of the mercury is here. So then you just measure from 0 to 100. Okay, how long, and then you just divide by 10. Okay, so that is how you calibrated the mercury. Or the next part, you can use the formula also. Okay, And the process of calibrator using the thermometer properties of liquid ingress. So this one is actually the expansion. Okay, the expansion. So let's say if you put in the hot water, it will expand the mercury. Okay, but let's say if you put in the cold water, it will contract, right? Okay, so this one, the one that I explained just now. Okay, lower point is a melting point, or upper point is a boiling point. Okay, so this is the experiment, the one that I said just now. You put in the ice to put in the hot water. Okay, yeah, this is the experiment I explained just now. You put in the ice, and this one you put the hot water. Okay, this is this is the experiment. Sorry, this is the formula. Okay, L theta minus L zero equals to L100 minus L0 times 100. Okay, so this is the formula. Okay, now, okay, I give you one question. Okay, I give you one question. Okay, how you want to find the L, find the temperature. Okay, not this one. Wait for a moment. Yeah, okay, so let's try to answer this question. Okay, I give you one example first, how you want to answer. Okay, so let's see question number 2 here. Okay, so it said here, right, the diagram below shows the land mercury when the water is at 0 degrees Celsius and 100 degrees Celsius. So find the temperature of theta. Okay, so L theta here is, if you see here, there is 3 cm, this is 4 cm. So L theta is 4 cm. So L0, the length of mercury when it's 0 degrees Celsius is 2 cm. Okay, while the L100, okay, is 9 cm. Okay, so the question asks you to find the theta. What is the temperature here? So we use the formula L theta minus L0 divided by L100 minus L0 times 100, right? So L theta is what? L theta is 4. L0 is what? L0 is 2 cm. Okay, L100 is what? L100 is 9 cm. L0 is 2 cm. Then you times 100. Can you find for me what is the answer for this one? Oh, sorry, teacher, this experiment can only be done with water. Yes, because we already know for the water, the boiling point is 100. They say if you use other liquid, so other liquid they have a different boiling point. Okay, so for water is already fixed, 0 and 100. So that's why we use the water. If you use like a mercury, the boiling point is very low. Okay, and I think but it's not like very low, like it's more than 100, and that means you need a longer thermometer, right? So better we use the water, because we already know the constant is that's the constant value, right? For the boiling water is 100, and for the water to freeze is 0. So that's why we use the water. 28.57 degrees Celsius. Okay, take 2 or 1 decimal point. Okay, take 2 or 1 decimal point. Okay, so can you understand for this part how you want to calculate the thermometer, the temperature for the uncalibrated thermometer? Right. Okay, so if you understand, can you try this one? This one, they ask you to find the length of mercury. They give you the theta. This one you need to find the theta, right? The temperature, right? Now they give you the temperature. They ask you for the length of the mercury. Okay, so use the same formula. Okay, and it already give you the melting point is 4 cm and the boiling point is 20 cm. So that's why I said they sometimes they say it freezing point, sometimes they call it melting point. But both is actually same. So L0. Okay. So take out first what is the info given, then you can use the formula. Maybe you still cannot remember. I just put here first. L theta minus L0, L100 minus L0 times 100. Okay, after this we do a short quiz, okay? I will call one by one, okay, to answer the question. And I already assigned homework, right? Homework for you, okay, in the Google Classroom. Please answer before 8 p.m. today. Okay. There are 13 objective question and also one structure. Okay. And answer the question in the test pad. Okay. If you don't have printer, then just use your test pad and write your answer. No need to copy down the question. Just write your answer in the test pad. Okay. And then snap the picture, change to PDF. Okay. So please change to PDF. Don't send me the image files. Okay, I don't want that because it's hard for me to mark. I need to convert it. Okay, so just convert directly to PDF. You can use the cam scanner. Okay, you can download it in the Play Store. Teacher, can we use a Google Docs? Google Docs. If you use a Google Doc, because Google Docs, I'm not sure because mine I'm using the PDF because I'm use a Kami app, so that's one they only can use maybe can lah Google Docs. I can open, but image no, because image I need to convert first. Okay, but for Google Docs yes, because I remember I marked someone send me Google Docs. Google Docs or PDF. But the one that I sent for you is already in the PDF form. 15.2. We can get 15.2. Any other answer? Maybe you got different one. Sajif got and Lakshmi, Nirupa, Tiga. So what is the L theta here? L theta is the one that you need to find. Okay. And then L0 is 4. L100 is 20 cm. Okay. So theta is 70. So the question is actually want you to find the length of the mercury when the temperature is 70 degrees, right? So I already give you the formula. Theta is L theta minus L0. L100 minus L0 times 100. Others is 7.2. Okay, Lashmi got 7.2. Kritiga, Nirupa, 15.2. Farah, Tajib, 15.2. So only Lashmi got 7.2. So let's see whether which one is correct. So theta is 70, right? So L theta minus L0 is L theta minus 4. L100 is 20. 20 minus 4 times 100, right? So 70. Okay, so this one the multiply I change to here, it becomes 0.7, right? 0.7 L theta minus 4, 16 here, right? So 0.7 times 16 plus 4 times 16 plus 4. So you get 15.2. Okay, very good. Ketiga, how you get 7.2? Lashmi, sorry. Lashmi, how you get 7.2? This one is divide 16, so change to here, it become multiply, right? And this one is minus 4 become plus 4. So the answer is 15.2 cm. Okay, so let's go to the quiz. I will call one by one. Okay, this is to check whether you are here or maybe you are still sleeping on your bed. Okay. Oh, why I'm doing? Sorry, wrong. Should be teacher. I didn't plus 4 but minus. Okay, so let's start. Okay, Abi Rami. So the most common temperature scale used in the world where water freezes at 0 degrees Celsius boil at 100 degrees is called the Abi Rami, are you there? Celsius. Okay. So Celsius, is it correct? Yes. Okay, it's a Celsius scale. Okay, Kelvin, you need to plus 2073. So it's using a different scale. So high temperature is connected to. Okay, Asha, are you here? Asha? High kinetic energy, correct? High kinetic energy. Okay, next one, Avinash. Heat transfer always goes from hot to cold. Okay, correct? Hot object to cold object. Okay, number four. Number four, Eugene. The hot water is added to cold water. Which of the following statement is correct if there is no heat loss to surrounding? So at this time, we call it's already reached the thermal equilibrium. Okay, so for this one, which one is the statement is correct? So remember, thermal equilibrium find three sentences. Whether it's a temperature is same, the heat transfer between two objects is same, and the net rate of heat transfer is 0. You just need to find these three sentences. So what is the answer, Eugene? Eugene? Eugene, are you here? Second, the blue, this one. Okay, very good. Okay, number 5. What happened to the particles at the heat up? Okay, Farah? What happened to the particle when you heat up the particles? Number 3, they slow down. Okay, just now someone said, right, the when you heat up, okay, the high kinetic energy, right? So high kinetic energy means the object move faster. So when the move faster means they speed up, not slow down. Slow down if you freeze the object. If you cool the object, then it will slow down. If you heat up the object, they will speed up because of the high kinetic energy. Okay, next one. You are walking to the school and find a meter earring in the snow. So you take the cold earring inside and place it on your desk. What will happen after a while? Okay, Janet, what is the answer? I'm sure we didn't have snow here. Janet, second, both the earring and the desk will be at the room temperature. Yes, because it reached the thermal equilibrium. Okay, number 7. After Janet is we can number the next question. Heating will continue until what it reach? This one is easy, equilibrium. Okay, and then Kritika, what happened to the temperature if I add ice cube to a glass of soda? The heat will what? Transfer from where to the first one? To cold to the ice, yes. And from the hot object to the cold object. All right, number 9, Lakshmi. Sorry, Krisha. You leave your cold spoon in a hot bowl of oatmeal. What happened after an hour? What will happen after 1 hour? Krisha? Number 4, the spoon and the oatmeal become the same temperature. Yes, it reached the thermal equilibrium. Okay, number 10, the unit joules for Lakshmi. This one is very easy. Joule is for what? This now we compare the temperature and the unit for the temperature. Lakshmi, number 3. Yes, heat energy. We answer until 16 only because I know after this you have a class, right? Okay, 11, two objects. So this one is Nirupa. Two objects V and W touch each other and the initial temperature of V and W are 90 and 80 respectively. Which statement is correct when V and W at the thermal equilibrium? What's the answer? Nirupa? Faster. Number 3, yes, the net rate of heat flow becomes 0. Okay, number 12, Raja. Heat always travel from first hot to cold. Okay, number 13, Sarindia. The liquid in the thermometer. This one I already tell what happened to the mercury when you heat the mercury. Number 2, it will expand. Okay, very good. Okay, number 14, Sajif. What happened to the particle as they cool down? This one I explained so. Number 1, they slow down. Very good. Okay, number 15, Sharanya. The sensitivity of the liquid in the glass thermometer can be increased by? What's the answer, Sharanya? For decreasing the size of bulb. Yes. so it will absorb the heat faster. So the condition where two of this one is Tava, okay? So where two substances in physical contact with each other exchange no heat energy, they are said to be the same temperature. So what happened here when we said that has the same temperature? Tava? Number 4, yes, thermal equilibrium. Okay, very good. So the rest I will discuss later. Okay. So thank you for today. So see you tomorrow. Okay, we continue specific heat capacity. Right. So make sure you do your homework. I give you the is in the Google Classroom. Okay. So thank you, class. All right. Bye. Welcome.
Thank you, teacher.
Welcome.
Thank you,
Bye
teacher.
bye. Bye.
Thank you, teacher. Bye, teacher.
Bye bye. Welcome.